In this video, we will solve equations involving exponents by taking a graphical approach. So let's look at this example. By graphing, let's solve the equation 2 to the x equals 3. So we'll solve this equation using graphing. So when we see this equation, we can think of this as the function f of x is equal to 2 to the x. So this left-hand side we can think of as the output of a function. So we'll write f of x equals 2 to the x, where y is equal to f of x. And then this statement, 2 to the x equals 3, is the same thing, since 2 to the x is equal to f of x, that's the same thing as saying f of x is equal to 3, which is the same as saying y is equal to 3. So if we plotted the graph of this function f of x equals 2 to the x, as well as the horizontal line y equals 3, we could find the intersection point of those two graphs to find the value of x that makes both of those things true. So if you plot those things into your graphing calculator, you should get two plots. Take a second to do that. The graph you get should look something like the following. We've got the graph of 2 to the x here in green. We've got the line y equals 3 here in blue, and they intersect at this point right here. So this xy pair is the only pair satisfying both of these relationships. So when x equals 1.58, y is equal to 3. And therefore, we can say that f of 1.58 equals 3. And therefore, this 1.58 is the solution to our original equation, f of x equals 3. So this value of x, 1.58, is approximately the solution to this original equation that we were looking at. So we can define functions to represent each side of this equation, and then find where those functions' graphs intersect, and look at the x-coordinate to find the value of x that makes the equation true. Let's look at one more example. So by graphing, let's solve this equation, 6 times 0.72 to the x equals 15 times 1.3 to the x. This looks like kind of a scary equation. Let's start by defining a couple functions. So first of all, let's look at the left-hand side and write that as a function. F of x equals 6 times 0.72 to the x, where y is equal to f of x. And then the right-hand side we'll write as g of x. So g of x equals 15 times 1.3 to the x, and where y is equal to g of x. So now we just took this left-hand side and the right-hand side of the equation and wrote them as functions. So we have f of x and g of x. We're letting those represent the output of two functions. So if we want to solve this equation, we're looking for values of x where f of x is equal to g of x. So we'll start by plotting both of those functions. So go ahead and do that now. The graph that you get should look something like the following. We've got this function graph f here in green, the function graph for g here in blue, and these two graphs intersect at one point. So negative 1.55, comma 9.99. So this is the xy pair that satisfies both of these functions, which tells us that when x equals negative 1.55, both functions have an output of about 9.99. So when x equals negative 1.55, both f of x and g of x equal this 9.99, and therefore f of x is equal to g of x. And so this x value here, negative 1.55, is the value of x that makes this equation true. So negative 1.55 makes f of x equal to g of x. And if we scroll back up, that value of x is what makes our original equation true. So the solution here, the value of x that makes this original equation true, is approximately, what did I say, negative 1.55. So when we approach things in this way, we can solve a lot of scary looking equations just by graphing.